And in 2048, that's 27 years, right? If I take the difference. So after 27 years, you have this many people. So the initial amount would be N naught, right? Would be the 156,784. So the equation is still the same. N of t equals N naught e to the kt, the one we just saw a few minutes ago. So I have to figure out what my decay or my growth factor is, meaning it's going to be positive because it's growing. You're getting more and more people coming to the city. So I have to figure out what this is going to be. So after 27 years, I have, this many people, 248,943. 248, not 84. Initially, 156,784. So that's 156,784 e to the k times 27. So after 27 years, you have 248,943 people. So this will enable me to figure out K, the growth factor. So we're doing part A right now. So solve it. So I have to divide both sides by 156,784. The numbers are really messy, but the math is still the same process. So we get e to the 27k if I divide both sides by 156,784. So if I take the ln of both sides, I can continue solving for k. So again, ln and e, they erase each other, or they cancel each other out. So I get 27k on the right side, just the power. So if I divide both sides by 27, I would have my decay constant. Of course, this is a really messy number, so I'm going to round it because it's messy. So if I take ln of 248,943 and divide it by that, it's just going to be, let's see what that actually is. So it's like doing ln of 1.58, 7808705 divided by 156,784 divided by 27. So 248,943 divided by 156,784 gives you 1.58, all this stuff, 1.587808,705. So if I divide that by 156,784, then I'm doing this. I'm taking the ln of 0.000010127 divided by 27 equals k. It's supposed to be a k. Actually, let me see, what's the problem? I think I divided it twice. That's not right. So actually what I should have done is you don't need to do this part. You don't divide that. That's just 1.58. So all you have is ln of 1.58. So let me just write it down better. I divided it twice. I should have only divided it once. I'll just write it again so it looks cleaner. So if I ln that, I get 0.4623548893. So if I divide that by 27, what do we get? K is approximately 0.017 if I round to 3 decimal places. 0.017. So notice that it's a positive number. With the last example, it was negative something. Because that was exponential decay, this is exponential growth. So the K is going to be positive.
When we write out this question on the exam, do we have to show the two steps where you had it ln of big decimal point and then
No. So you don't have to do all this stuff
equal divided by 7, or can we just go from ln the fraction divided by 7 to the answer?
You mean this fraction here? Or...
Yeah, because if you take ln of that fraction and you divide that by 7, you get the answer. Do we have to show the several in-between steps, solving that and then doing the ln of that number?
Maybe you don't have to do as many steps, but you should probably do at least a couple steps, right?
Okay.
You have to show, you're supposed to show work on this too. So I show a lot of work when I'm doing when I lecture. But it's not necessary to do every single step, but you got to show me the primary steps maybe. Yeah. Okay, so that's part A. So part A was getting the growth factor. The growth factor was what we just found, positive 0.017. So then I tell you to model it in part B. That's the easy part. Getting K is harder, but modeling it is easy because you have everything that you need. So the initial amount is given to be the number of people in 2021. So in 2021, there's 156,784. Okay, so that's going to be my initial amount. We're starting in 2021. So we have 156,784 e to the kt. So that's 0.017t. That's your exponential model for this situation. So I ask you, how many people are going to be living in 2022? In 2200, I mean. So in the year 2200. Well, we started in 2021, right? That's our starting point. So my T is going to be 2200 minus 2021. Which is, 179 years. So I have to figure out how many people. So I want to figure out n of 179 is my question. You're going to put in 179 for T and then figure out what n is. So I just have to plug in 179 for T, two different spots. So if I do this a long way by hand, I know E is 2.71828. So if I times 0.017 by 179, we get 3.043. So I have to do all the math here and I have to do the exponent before the multiplication, as always, PEMDAS. So if I raise 2.71828, which is e to the 3.043 power, we get 20.968011021. So since we're dealing with people, I rounded to the nearest whole number. So the answer comes out to approximately 3,287,449 people in 2200, right? The year 2200. This many people, approximately. So yes, if you have a good calculator, you don't have to do as many steps. But it's a good idea to see where it all comes from. And then you know where I'm getting it from step to step. Any questions about it? Does it make sense?